Usually when we talk about a medical diagnosis, there's this real expectation of precision.
Right, yeah, like it's a hard science.
Exactly. Like it's basically engineering. You break your arm, they take the x-ray, it shows that jagged white line, and the doctor just points and says, there it is.
It's binary. It's either broken or it's not broken. The visual evidence perfectly matches the physical reality of the situation.
Yeah, but then you step into the world of, say, neurodevelopment or maybe autoimmune diseases, and suddenly that x-ray machine it's useless.
Completely useless.
Right. We're looking at a diagnostic landscape that is just incredibly murky.
Oh, for sure. It becomes this massive game of interpretation. You're looking at symptoms and you're just trying to reverse engineer the invisible systems causing them.
And that murkiness, that massive gap between what we can visualize and what is actually happening beneath the surface, that is exactly what we are seeing right now in the technology sector. Right now, as you and I are literally sitting here speaking, global corporations are burning millions of dollars, paying highly skilled, senior software engineers to act as the highest paid art critics on Earth.
It's a staggering misallocation of human capital. Truly staggering.
I mean, they're spending, 20 hours a week just squinting at monitors?
Right.
Arguing over an 8-pixel margin on video calls.
Right, trying to guess the exact hex code of a blue rectangle.
Yes. They are looking at a picture and trying to reverse engineer a functional system, and it is absolutely breaking the industry.
The translation layer is completely broken down.
So today, our mission for you is to really explore this trillion-dollar blind spot in product development.
The design to engineering handoff.
Exactly. And we have a massive stack of sources to unpack for this deep dive. We are looking at deep technical guides on AI-powered code generation from places like Monorail, A-Designer, and Duple.
Yep, some heavy technical reading in there.
It's very heavy. We also have enterprise alignment frameworks from Nesenia and Miro, and we are diving into some incredibly raw, just unvarnished Reddit threads.
Those Reddit threads they are spicy.
Ooh, they are aggressive. And we're pairing those with a viral, highly confrontational industry manifesto by Prasad Bond.
What's fascinating about this whole stack of sources is just the stark contrast. You have these high-level, sterile enterprise architectures on one side.
Right, the utopian corporate view.
Yeah, and then this ground-level, visceral frustration from the developers actually doing the grunt work on the other side.
And here is why you, listening right now, need to care about it.
Yeah, the stakes are high.
Whether you're scaling a massive enterprise or, maybe you're just a solo developer hacking together an MVP on your weekend, the friction of turning your idea into a functional product is bleeding you dry.
It's costing you time, it's burning your runway, and it is destroying morale.
Absolutely destroying it. So today we are breaking down the tools, the math, and the radical mindset shifts required to fix it.
And we should mention, we're going to look at this heavily through the lens of the legendary industrial designer Dieter Rams.
Oh yes, applying his philosophies of functional, honest design to this digital assembly line.
Right, because Rams famously believed that good design makes a product understandable, and more importantly, that good design is as little design as possible.
Which is, right now the software industry is doing the exact opposite of that.
The total opposite. It's maximalist chaos.
So let's establish the baseline here. What exactly is happening in this handoff phase? I want to break down the statistical reality from the source data, because when I read this, my jaw actually dropped.
The numbers are brutal.
They are. According to industry research, 65.9% of professionals are wasting 25 to 50% of their time on design delivery inefficiencies.
Let's really pause on that number. Half their time.
Half.
Right. So if you have an engineer earning $150,000 a year, you are paying them $75,000 to essentially act as a human translator for a drawing.
It's insane. And let's scale that up for a second.
Yeah.
For a typical 10-person product team, assuming an average blended rate of, say, $75 an hour, that equates to roughly $58,500 burned every single month.
Over $500,000 a year, just completely vaporized into thin air.
But the statistic that really, really got me was this one. 67% of developers admit that they spend significant time recreating designs completely from scratch.
Oh, yeah. Rather than working from whatever was handed to them.
They just throw it out.
They do. They look at the file the designer spent, 3 weeks perfecting, sigh heavily, and then just open a blank code editor.
Why? Why is that happening? I found this brilliant analogy from one of the Reddit threads we analyzed, and it perfectly captures this.
Oh, the pie one.
Yes. One developer described the traditional design handoff like this. They said, it's like giving someone a pie pan, dropping them off at the grocery store, and expecting them to bake a pie.
It's so accurate.
You're handing them a static Figma file, which is essentially just a mood board. It shows what the pie looks like.
But the developer needs functional behavioral logic.
Right. They need the recipe, the oven temperature, the exact sequence of ingredients. We are playing a trillion-dollar game of visual charades.
Visual charades is a perfect way to phrase it, and the sources point to Miro's analysis to really explain the mechanisms behind why this charade keeps happening.
Let's get into Miro's breakdown.
Yeah, so Miro identifies 5 structural breaking points in the modern handoff. These are the specific chasms where the context just totally falls apart.
Okay.
The first one they call the context switching tax.
Oh man, I see this constantly. Everyone is living in completely different digital universes.
Precisely. The developers are immersed in their IDE, their integrated development environment, just staring at lines of code.
Right.
The designers are living in Figma, manipulating vectors on this infinite visual canvas. And then the product managers are writing user stories over in Jira.
So they're all siloed.
Exactly. When you constantly switch between these tools, the why behind a design decision is completely severed from the what.
Give me an example of what that looks like in practice.
Okay, so a developer sees a checkout flow with a specific sequence of input fields, but what they don't see is the 6 weeks of user research that proved customers abandon their carts if there are too many fields on the first screen.
Oh, I see. So the developer, lacking that context, might look at the design and think, well, it's much more efficient for the database to just collect all this information on one single page.
Right, because they're thinking like an engineer.
So they consolidate the fields to make their code cleaner, completely unaware that they just destroyed the product's conversion rate.
Because they only see boxes on a screen, they don't see the intent behind the boxes. This is exactly where Dieter Ram's principle that good design makes a product understandable fails in software.
Because the design might be understandable to the end user eventually, but the mock-up isn't understandable to the engineer building it.
Exactly. Which brings us to the second breaking point from Miro, the happy path fallacy.
Designers love the happy path.
Oh, they live for it.
The happy path is this beautiful utopian scenario where absolutely everything works perfectly. The user has a conveniently short, phonetically pleasing name like Jane Doe.
Right. It always is perfectly on one line.
Exactly. The database responds in 0 milliseconds. The user's internet connection is completely flawless. The sun is shining.
But developers have to build for reality, and reality is chaotic.
Yeah, things break.
What happens when the API fails?
Let's explain what that actually means for the listener who might be more on the product or design side.
Sure, yeah.
So an API, an application programming interface, is essentially the messenger that takes the user's request from the front-end interface, runs to the back-end server or database, and brings the data back.
Perfect explanation.
So a user clicks Submit Payment. The API runs to Stripe. But what if Stripe's servers are down? Or what if the user is on a train going through a tunnel and their 5G drops exactly as they hit Submit?
Then the API times out. The request fails. Now, what does the screen do?
Right, the Figma file doesn't show that.
Almost never. A static Figma file rarely shows the skeleton loader, or the timeout error toast, or the specific copy telling the user not to click Submit again.
And if those what-if questions aren't explicitly answered in the design,
the developer has to stop their workflow and ask. Or worse, and far more commonly, they just guess.
And they guess badly.
They throw in a generic browser alert box that says error 500, which absolutely terrifies the user.
Because they guess in a way that is easiest to code, not what provides the best user experience. Which leads directly into breaking point number 3, the static mockup problem.
This one is huge.
A static image can show you what a button looks like, sure. It can show you the gradient and the drop shadow. But it cannot dictate the feel of it.
The kinetic energy is missing.
Right. If I hover over that button, does it transition in 200 milliseconds or 400 milliseconds? Does it slide up? Does it fade in? Does it pop?
This is a critical distinction in design theory. A static mockup is obtrusive by nature because it forces the viewer to infer its function.
It doesn't explain its physics.
Exactly. If the front-end developer guesses the transition timing and they make it, say, 500 milliseconds, the interface suddenly feels sluggish. It feels janky.
It feels cheap.
And that subtle, unconscious feeling completely destroys the user's trust in the product. The original design intent was premium, but the executed code is sluggish because a static picture just cannot carry kinetic data.
Then you hit the fourth point in Miro's breakdown, async communication loops, the endless, soul-crushing Slack delays.
The bane of every product team.
A developer runs into that API error state we just talked about.
Yeah.
They realize the designer didn't create a screen for it, so they ping the designer on Slack, hey, what should the error state look like here?
But the designer is in a 3-hour sprint planning meeting.
Right, so they reply at 4:00 p.m. By then, the developer has context switched to a completely different Jira ticket. They see the reply the next morning.
A single missing error state just added an entire 24 hours to the project timeline.
And this compounds exponentially across a massive enterprise application.
And finally, we have the fifth breaking point, late feedback.
The big reveal.
Because of how these silos operate, developers are often only invited to look at the design when it is deemed final by the stakeholders.
The designer proudly unveils this complex, beautiful dashboard.
And the senior engineer immediately points out that the back-end architecture does not support the data structure required to render that dashboard in real time.
We don't have an endpoint for that data. It's the phrase that kills 1,000 designs.
Exactly. But at that point, the design is supposedly finished, so pivoting is incredibly expensive.
You either rewrite the entire back-end architecture to accommodate a picture, or you throw away weeks of design work.
There's no good option.
So, okay, if everyone knows this is fundamentally broken, if 2/3 of developers are literally tossing the designs in the digital trash and starting from scratch, why are we still handing over flat images and calling it a day?
Well, the solution proposed by Miro, and echoed across multiple enterprise frameworks we looked at, is the formal introduction of a logic layer.
A logic layer.
Yes, we have to stop thinking of the deliverable as a set of pixels. Teams must document user flows, state diagrams, and conditional logic.
We have to document the why and the how, not just the what. It's the recipe, not just the picture of the pie.
That's it. You use tools like Miro or FigJam not just for brainstorming, but as the actual structural bridge.
So you're building interactive logic maps.
Exactly. Annotated logic maps that explicitly state, for example, user clicks submit, API is called. If API fails, trigger this specific error component. If API succeeds, trigger the success animation.
You map out the behavioral logic visually so the front-end developer doesn't have to play detective.
You elevate the design from a mere picture to a logical schematic.
Okay, I understand the theory behind the logic layer, but let's be real for a second. If handing over a static image is such a massive trillion-dollar failure, how do other industries handle this?
That's the million-dollar question.
Because building a skyscraper or manufacturing a physical car seems infinitely more complex than building a web app. And yet Boeing and Ford managed to do it without the mechanical engineers and the factory workers having a passive-aggressive Slack war over an 8-pixel margin.
This is exactly where we shift to the viral manifesto from Prasad Bond found in our sources.
Oh man, this piece of writing.
It is brilliant. It's a highly aggressive piece of writing that really crystallizes the absurdity of the software industry. Bond argues that software development is operating 40 years behind physical manufacturing.
Let's talk about the CNC machine comparison he uses in his manifesto.
Yeah.
Because when I read this, it completely rewired how I think about front-end development.
It's a fantastic analogy. In industrial manufacturing, when a mechanical engineer designs a physical part, let's say a titanium turbine blade for a jet engine,
Okay.
they don't hand the factory machinist a beautiful shaded watercolor painting of the blade and say, make it look roughly like this, just eyeball the curves.
Right, because the plane would crash.
Exactly. They export strict, uncompromising mathematical tolerances. They generate something called G-code.
Decode.
Yeah, which is a programming language that directly controls the automated machine tools. That code is fed directly into a CNC machine. The raw data directs the physical output.
So the output matches the digital intent perfectly every single time, down to the micrometer.
Yes, but in software.
In software, Bond argues, we send a watercolor painting of a sink to a plumber, and we ask the plumber to figure out the torque specifications for the pipes based on how the painting makes them feel.
It's completely absurd when you put it like that.
We are the only engineering discipline on the planet that tries to build complex, functional, load-bearing systems from flat, static pictures.
And Bond's solution to this is what he calls the 48-hour protocol.
And I have to say, looking through the sources, this protocol is a radical departure from how 99% of design teams work today.
It requires a fundamental shift in authority and workflow.
Break this protocol down for us, because I want to know how you practically apply sheet metal tolerances to digital pixels.
Okay, so the 48-hour protocol demands that you extract all core dimensional variables of your design.
Made up.
Your spacing units, your typography scales, your brand color hex codes, your border radii, you strip all of that out of the visual design tool entirely.
You pull it out of Figma.
Yes, you put them into a single, centralized master JSON configuration file.
Now, for anyone who isn't deep in the code, let's define JSON's role here real quick.
Sure.
JSON stands for JavaScript Object Notation. It's really just a standard text format for storing data. But in this context, by putting your design variables into a JSON file, you are removing human interpretation.
Right.
You're turning a color from a subjective visual preference into an unchangeable, hard-coded mathematical variable that the compiler reads natively.
Precisely. You map this JSON file directly to your front-end compiler. It becomes the absolute, unassailable source of truth. And the protocol demands that you remove manual CSS overrides from the developer's workflow entirely.
Wait, meaning the developer is physically locked out from making aesthetic choices?
Yes. A developer cannot just hard code a 12-pixel margin because they feel like it, or because they couldn't clearly measure the Figma file. The code must obey the raw data in the JSON file.
That is intense.
And here is the truly radical part of Bond's protocol. If a visual designer wants to change a design element, say they want to increase the padding on all secondary buttons across the app,
Okay.
they don't tweak it in Figma and send a Jira ticket asking the developer to update it. The designer must open the code repository and edit the JSON file themselves.
Wait, hold on. You're telling me that a visual designer, someone who was likely hired for their eye for aesthetics, their understanding of user psychology, their mastery of typography, is now being forced to open a code editor, write JSON syntax, and commit it to a repository.
That's the protocol.
That sounds like a recipe for an absolute mutiny. Doesn't that completely destroy the fluid creative process? Like, how do you ideate if you're writing data structures?
It sounds restrictive, I know. But this is exactly where Dieter Ram's philosophy shifts from abstract theory to a practical tool.
How so?
Ram's advocated for purity, for stripping away the non-essential. When you enforce a JSON configuration file, you are applying that philosophy at a systemic level. The argument here is that constraints actually breed clarity.
So by removing the micro decisions, you free up cognitive load for macro decisions.
Exactly. Think about the friction we discussed earlier. If you completely remove the 45-minute Slack debate over whether a margin should be 8 pixels or 10 pixels.
Because the JSON file mathematically dictates that all minor container margins in this application are 8 pixels. End of story.
Right. You free up the designer. They are no longer pushing pixels. They can focus on the actual user experience.
They can focus on the psychological flow, on accessibility standards, on the hierarchy of information.
And the developers are free to focus purely on architecture, state management, and performance.
You are forcing both sides to respect the medium. And this isn't just theoretical posturing, right? The sources actually back this up with physical product handoff data from a company called Viscom.
Yes, Viscom's data illustrates this parallel perfectly. When you design physical hardware, you don't just hand over a 3D CAD file to the factory.
Right.
You provide explicit written documentation of intent. You document why brushed aluminum was chosen for the casing over a cheaper powder coat, explaining the thermal dissipation properties required.
It's the why again.
Exactly. You define explicitly which 3mm radii on the chassis are critical to the structural integrity of the device and which radii are flexible, allowing the factory engineers to optimize the tooling for mass manufacturing.
You separate the non-negotiables from the flexible.
Exactly. Software needs this exact same explicit documentation of intent. The JSON file acts as the non-negotiable structural integrity.
Okay, so I buy the premise. We need to move away from watercolor paintings and embrace strict engineering geometry.
Yes.
But let's look at the reality of scaling this. Enforcing a master JSON file across a massive 2,000-person engineering team creates an entirely new problem: human error.
Oh, absolutely.
You cannot have 200 different designers manually updating JSON syntax without eventually breaking the build. To execute this strict sheet metal precision at an enterprise scale, we have to bypass the human translation step entirely.
And that necessity is exactly what has fueled the massive explosion of AI-powered design-to-code tools over the last 2 years.
Right.
We're witnessing a profound technical shift from static design plugins to intelligent prompt engineering and AI generation.
I want to trace this evolution because it didn't happen overnight.
Yeah.
Where did we start with this translation problem, and where are we standing right now?
Okay, so we started with traditional legacy plugin workflows, tools like Zeppelin.
Zeppelin's been around forever.
Right. It's been an industry standard for a long time, and it's fantastic for what we call spec-first delivery. Zeppelin automatically pulls the measurements, the spacing, and the color hex codes out of Figma so the developer doesn't have to manually measure things with a digital ruler.
It automates the redlining process.
Right. But it doesn't write the structural code.
Okay.
Then came the next wave. Tools like the early iterations of Anima, which attempted to actually export basic React, HTML, or Vue code directly from the visual canvas.
But the output of those early tools was famously awful.
It was terrible.
It generated what developers derisively call div soup.
Div soup, yes.
For anyone who hasn't stared at bad front-end code in a while, div soup is essentially when the code uses thousands of deeply nested, semantically meaningless HTML tags just to force a visual layout.
Right, it's a nightmare to read.
It's like trying to build a house out of thousands of identical tiny Lego bricks instead of using proper structural walls and support beams. From the outside, it looks exactly like a house.
But if you try to replace a window
or change the layout, the entire structure collapses because there is no underlying logic holding it together.
That's a perfect analogy. The early tools generated the visual facade but lacked deep architectural logic. It was impossible to maintain.
So what changed?
Now, we are entering the era of AI first generation. These new models actually understand context, and the sources provide an incredibly compelling cost-benefit analysis between two of the heavyweights currently dominating this space. Locify and Builder.io.
Let's do a deep dive on these two because they represent very different approaches.
Yeah.
I was looking at Locify in our notes, and what struck me is how heavy the underlying technology is.
That's very robust.
Locify uses what they call large design models, or LDMs. It is designed to generate highly modular, production-grade code across a variety of frameworks, but it specifically excels in React and Next.js.
Yeah, that's their bread and butter.
But it's not magic, right? It requires a heavily guided tagging system inside Figma.
Yes, the human is still very much in the loop during the setup fills. The designer has to manually tag the visual elements. They're basically telling the AI, this rectangle is a primary button, this text box is an email input field, this section is a responsive navigation bar.
Which sounds like a massive upfront time investment.
It is. Depending on the complexity, it can take 30 to 60 minutes just to prep a single complex file before you even attempt to generate the code.
But where I get stuck on Locify is the pricing model. They use a token-based pricing structure. According to the Montreal analysis provided in our sources, it costs roughly $80 to $120 to generate a single complex screen.
It's not cheap.
Over $100 just to generate the code for one dashboard. How is that sustainable for a fast-moving product team that iterates constantly?
Well, the short answer is it isn't sustainable for constant, rapid iteration on small teams.
Right.
Locify's model is incredibly powerful for massive, well-defined component libraries where you need absolute pixel-perfect accuracy translated into code once and then heavily reused.
Got it. So you pay upfront for the accuracy.
Exactly. But it is expensive. Now, on the other side of the ring, we have Builder.io's Visual Copilot. And this tool approaches the problem entirely differently.
Explain the mechanism behind Builder.io because it seems to solve the div soup problem at a fundamental level.
It does. Builder.io combines AI with an open-source compiler they built called Mitosis. And this is where the engineering gets truly brilliant.
Okay, lay it out.
Instead of trying to write React or Vue code directly from a picture, Mitosis takes the visual component and parses it into an abstract syntax tree, or an AST.
Okay, break down an AST for us. What is that?
Think of an AST as the pure framework-agnostic DNA of that component. It strips away the specific syntax of React or Angular and just maps the core logic.
Because it's just the bones.
Exactly. It maps things like, this is a container, inside is text, inside is a button that triggers an action.
Okay, I follow.
Once it has that pure DNA structure, Mitosis uses framework-specific generators to compile that AST into highly optimized clean React, Vue, Svelte, or Angular code. Because it starts with the structural DNA rather than the visual surface, it completely eliminates the div soup.
That is fascinating. And the cost?
Because of this architecture, it is a fraction of the price of LDMs. We're talking roughly $3 to $5 per screen.
Unbelievable. But the compiler isn't even the part of Builder.io that gave me a massive aha moment when I was reading the sources.
That's the mapping, isn't it?
It's their AI component mapping. Builder.io doesn't just spit out generic code. It maps the Figma design directly to the company's existing proprietary code base.
This is the critical innovation for enterprise design systems.
I want to make sure the listener really understands the gravity of this, so let me use an analogy here.
Go for it.
It's the difference between asking an AI to look at a picture of a car and paint you a matching picture of a tire versus asking the AI to walk into the factory warehouse, find the exact Michelin tire we already manufactured, and bolt it onto the car.
That is exactly what it's doing. Let's look at how this works under the hood. In a massive enterprise, you already have a coded, functional, heavily tested submit button living in your code repository.
Right, it's been approved by 50 people.
Exactly. It has all your accessibility standards, your hover states, your loading animations already baked into the React code.
Okay.
In traditional AI translation, if a designer draws a new submit button in Figma, the AI will write 100 lines of brand new HTML and CSS to recreate the visual look of that button.
So you end up with duplicated parallel code. You have your official button and this new imposter button that looks the same but isn't.
Which becomes an absolute nightmare to maintain.
Because if the branding team decides to change the primary button color from blue to purple a year later, the official button updates. But the imposter button generated by the AI stays blue. The system fractures.
Precisely. But with Builder.io's component mapping, you link your Figma components to your actual code repository. It uses vector embeddings and AST reading to analyze the intent. When the AI scans the Figma file and sees that visual button, it doesn't generate new CSS. It realizes, this matches the enterprise standard button.
So what does it write?
It simply outputs a reference to your existing proprietary React button component. It writes one single line, open bracket button variant equals primary close bracket.
That is Dieter Rams's honest design applied to the actual code base.
It really is.
It's not creating a superficial illusion of the button. It is structurally utilizing the real functional button.
And when you implement this level of architectural mapping, the productivity gains are just undeniable. The sources quantify this with massive ROI data.
Yeah, let's hear those numbers.
Take Alibaba, for example. Alibaba is a behemoth.
Massive.
They implemented strict design-to-code automation using component mapping. They saw a 50% faster handoff time, but more importantly, they saw a 65% decrease in the overall size of their front-end code base.
65% of their code was just redundant garbage. They eliminated all that duplicated div soup.
Sparkbox, an agency, tracked their metrics and saw a 47% reduction in task time.
Wow.
And the most staggering statistic comes from Eventbrite. By adopting strict design systems and component mapping, Eventbrite calculated that they saved 534 days of engineering effort.
Let that sink in. 534 days. That is a year and a half of a senior engineer's life given back to the company.
It's incredible.
If you calculate the salary and overhead on that, that is millions of dollars in runway saved just by enforcing a logic layer and component mapping.
It proves mathematically that when you treat pixels like tolerances, when you enforce the logic layer, the bottlenecks dissolve.
But here is the reality check. How you apply this technology depends entirely on the scale of your operation.
Completely. Context is everything here.
A solo developer building a SaaS MVP on the weekend has vastly different needs and constraints than a global corporation like Spotify. So let's talk about scaling the solution. Let's start with the enterprise perspective.
Okay, if we look at enterprise architecture, the primary pain point isn't just generating code faster, it's enforcing absolute consistency across multiple platforms.
Right.
If you are a bank, you need the iOS app, the Android app, and the web dashboard to feel absolutely identical.
And to achieve that omnichannel consistency, the enterprise world relies heavily on design tokens.
Yes. Design tokens take that JSON configuration idea we discussed earlier to the enterprise level. They are the atomic, platform-agnostic values of a design system.
Explain how that works practically.
You don't say color blue. You say brand primary 500. We are seeing a whole ecosystem of tools emerging specifically to manage this scale. Like what? Supernova, for instance, acts as a centralized brain managing design tokens across platforms. It pushes updates directly to the various code bases.
So the workflow looks like this, right? The lead designer decides the primary brand color needs to shift slightly. They change brand primary 500 from light blue to dark blue inside Supernova. Supernova then automatically updates the CSS files for the web team, translates it into Swift code for the iOS app, and translates it into Kotlin code for the Android app, pushing all those updates simultaneously to GitHub.
Exactly. It removes the human translation step across all platforms at once.
That's powerful.
Then you have tools like Zero Height, which act as living documentation synced directly to Figma, so developers never have to ask what the standard is. It's right there in their workflow.
And UX Pin Merge takes it even further, right?
Oh, UX Pin merges is wild. Designers using UX Pin actually build their visual prototypes using the real React components pulled dynamically from the engineering repository.
It completely erases design dev drift because the mockup is the literal code.
Exactly. And the sources mention a specific case study with Spotify that beautifully illustrates why this enterprise consolidation is so critical before you even attempt to introduce AI tools.
Yeah, Spotify's situation was a monumental organizational challenge.
A nightmare, really.
A few years ago, they had 200 designers and 2,000 engineers building software for 45 different platforms.
Think about it. They have the desktop app, the mobile app, but also interfaces for car dashboards, Apple Watches, smart speakers, and Samsung refrigerators.
And across this massive footprint, they had 22 disparate design systems floating around.
22 distinct design systems for one company. That is the definition of organizational chaos.
Imagine a user opening Spotify on their fridge, and the play button looks slightly different and behaves differently than on their phone. It fractures the brand identity.
It creates cognitive dissonance for the user and maintenance hell for the engineers. So Spotify executed a massive consolidation project.
What do they do?
They brought those 22 scattered systems down into a unified Encore family of just 4 connected systems, all bound together using shared design tokens.
And once you have that unified architecture, then you can apply AI component mapping effectively.
Right. But even with a perfectly unified system, enterprises don't always want an AI tool to generate an entire page of code.
No, that would be overkill.
Sometimes a developer just needs to add a single new feature to an incredibly complex pre-existing page. They don't want an AI rewriting the whole file.
That's where the concept of surgical AI comes in. Instead of full-page generation, enterprise developers are utilizing Figma MCP, the Model Context Protocol.
I've seen this acronym popping up everywhere. Explain how MCP works under the hood and what it looks like in practice.
Okay, let's put you in the shoes of a developer. You are working in your IDE, perhaps using a modern AI coding assistant like Cursor or GitHub Copilot.
Okay.
Your product manager asks you to add a new analytics widget to an existing dashboard. In the old workflow, you'd open Figma, look at the new widget the designer drew, and manually type out the code to match it, trying to fit it into your existing layout.
Right, lots of alt-tabbing between windows.
Exactly. With Figma MCP, you don't do any manual translation. MCP doesn't just copy an image. It exposes the underlying JSON data and spatial relationships of that specific Figma frame to your local IDE server. You simply select the specific frame containing the new widget in Figma, and you pass that context directly into your IDE.
So you just prompt it.
Yeah. You prompt Cursor, build this new widget using our existing React components, and insert it into my current layout below the header.
That's incredible.
The AI reads the exact spacing, the design tokens, and the text from the Figma file, and surgically injects the code into your established architecture without touching the rest of the file.
It's a precision instrument. It's not tearing down the whole house just to add a new window.
Okay, so that is how the massive enterprises are scaling this. But if you're listening to this and you're a solo developer or a startup founder, you're probably thinking, I don't have a massive component library. I don't have 200 designers. None of this applies to me.
Right.
But actually, this is where the tools get arguably even more disruptive. What if you want to skip Figma entirely?
This brings us to the emerging trend of prompt to production.
Prompt to production.
Yeah. If you are a small team and you don't have an established design system that you need to protect and map to, you can bypass the visual translation step entirely. I might argue that for rapid MVPs, Figma itself is becoming an unnecessary bottleneck.
We're talking about tools like A-Designer, V0 by Vercel, and Teleport HQ.
The workflow here is fundamentally different than anything we've discussed. You don't open a canvas, you don't draw boxes, you don't select fonts.
So what do?
You literally type a text prompt. You type, generate a sauce pricing page with 3 tiers, a dark mode toggle, and gradient accents.
And what actually happens? Walk us through the output.
In seconds, the AI generates the visual user interface and writes the underlying HTML, CSS, Tailwind, or React code simultaneously.
Both at once.
Both at once. You see the rendered page on your screen, and right next to it, you see the clean, deployable code. If you don't like the layout, you don't drag things around with your mouse. You type, make the middle pricing tier pop out more, and change the primary color to emerald.
And it updates.
The code rewrites itself instantly.
It's conversational development.
Exactly. And tools like A-Designer even offer one-click publishing with custom domains built right into the platform.
You can go from an abstract idea in your head to a live hosted website in minutes without ever opening a visual design tool.
That is incredibly powerful for MVPs. It removes the entire friction of handoff because there is no handoff. The design is the code.
It perfectly embodies Dieter Rams's belief that good design makes a product useful.
Exactly. By removing the abstract drawing phase and moving directly to functional code, the tool ensures the product is immediately useful and testable in a browser environment, rather than just looking pretty on a static canvas.
Okay, we have to talk about the elephant in the room.
Oh, here we go.
We have these incredible tools, AI component mapping, surgical MCP integration, prompt to production. But as our sources point out, tools do not fix toxic culture.
No, they don't.
If your team hates each other, faster code generation won't save you. And that brings us to the very spicy Reddit discourse we analyzed. There is a very loud, very aggressive crowd online screaming that Figma is dead and the role of the designer is over.
It's a provocative claim, but we need to critically examine who is actually making it and why.
Right. I was laughing out loud reading through these Reddit threads because it seems like the Figma is dead crowd mostly consists of two distinct groups.
Who's in the first group?
First, you have the AI bros with zero aesthetic taste, who think that just because they can generate a generic, soulless Tailwind template using V0, it makes them a master product designer.
Right, the tech-first crowd.
And second, you have deeply frustrated developers who are just thrilled they never have to talk to a designer or argue about padding ever again.
Well, I think you're romanticizing the prompt-to-production output slightly, and those developers are definitely doing the same. But it highlights the real cultural friction here.
What's the core of that friction?
The technology is advancing much faster than the human ability to adapt to it. Developers often complain that AI, even the good tools, still generates bloated code that lacks proper security architecture.
They hate having to clean up the machine's mess.
Exactly. And the designers are absolutely terrified.
Because they're losing control.
They fear that if the industry shifts entirely to prompt engineering or coding directly, like forcing them to use Claude code in the terminal, it destroys their experimental canvas.
Figma is a safe space to play. You can drag things, break things, iterate wildly.
If you force a designer to just write prompts, they lose the ability to easily iterate visually. They feel like they're being turned into data entry clerks.
Both of those fears are entirely valid. You cannot automate empathy, and you cannot automate creative exploration.
And this is exactly why the enterprise framework from Nesenia caught my attention. They developed the Bridge framework.
Let's get into Bridge.
It's a structured 90-day plan to actually fix the human element of this misalignment, ensuring the tools enhance the culture rather than destroy it.
Let's unpack the acronym, because I think this is highly actionable for the listeners. Take us through a real-world scenario for these steps.
Okay, let's start with B. Build shared understanding. This isn't just a corporate buzzword. It means creating a literal shared glossary.
Give me an example.
A designer and a developer are in a meeting. The designer says, we need to optimize the user flow. The designer is talking about the psychological customer journey, how the user feels navigating from the homepage to the checkout.
Right.
But the developer hears user flow and thinks about the sequence of API endpoints and beta payloads.
They're having two completely different conversations using the same words.
Exactly.
Yeah.
Building shared understanding means establishing definitions so you are actually speaking the same language.
That immediately de-escalates so much conflict.
Okay.
What's R?
R is for routinized communication. This means restructuring daily stand-ups. Instead of everyone just reading a list of what JIRA tickets they moved, the stand-up focuses exclusively on blockers and handoff points.
So they'd say something like, I am passing this JSON configuration to engineering today. Are there any architectural blockers?
Exactly. It's about flow, not just status.
Next is I.
I is integrate tools. This is crucial. Don't force people out of their native environments. Don't force designers to live in GitHub. And don't force developers to live in Figma.
So how do they communicate?
Use integrations to link them. Have Figma comments automatically generate JIRA tickets with the full context attached.
Let the tools do the context switching. I love that. D is next.
D is define criteria. Have a shared, mathematically defined definition of done. A feature isn't done when the Figma file is polished.
When is it done?
A feature is done when the code is deployed, the accessibility contrast ratios pass the WCAG standards, and the component maps correctly to the design tokens. You measure the final product, not the picture.
T.
G is govern with metrics. Stop guessing how bad the bottleneck is. Actually track how much engineering time is spent on UI revisions. Measure the exact cost of the friction.
And finally, E.
E is evolve continuously. The tool stack will change in 6 months. The culture needs to be resilient enough to adapt to the next version of Builder.io or the next iteration of Figma MCP without collapsing.
It's about building organizational empathy as much as it is about building software. And there is a crucial technical takeaway that ties into this cultural shift, something that every developer and PM needs to understand: the AI refactoring pass.
This is perhaps the most important expectation to set when implementing these tools. No AI tool on the market today, not Builder.io, not Locify, not V0S, produces 100% flawless production-ready code on the first click.
You cannot just copy-paste the output and hit deploy to production. If you do, you are going to break things.
You must architect your timelines to expect 20 to 40% manual refinement time.
That's a significant chunk.
It is. The generated code is a high-quality starting baseline. It gives you the structure, the layout, the CSS, and the basic mapping. But it is not the finished product.
So what does the human actually do?
The human developer still has to wire up the complex global state logic, ensure deep accessibility compliance for screen readers, and write the logic for the extreme edge cases that the AI couldn't anticipate.
So the developer's job isn't gone, it is just shifted up the value chain.
Precisely.
They're spending significantly less time acting as art critics, recreating CSS margins and fighting over hex codes, and spending vastly more time on actual software architecture, security, and performance.
Exactly. The AI acts as a powerful accelerator, but it is not an autopilot. You still need an engineer at the wheel.
So what does this all mean for you, the listener? Let's summarize the incredibly dense journey we've been on today.
It's a lot to take in.
We are witnessing a massive paradigm shift in how digital products are built. We are aggressively moving away from treating software design like a watercolor painting, a vague, subjective representation of visual intent that requires hundreds of hours of manual human interpretation and guesswork.
We are moving towards strict engineering geometry.
Whether it is through Prasad Bond's radical demand for master JSON configuration files, or enterprise teams utilizing Builder.io's AI component mapping to enforce design systems, or solo founders skipping the canvas entirely with direct prompt-to-production tools like V0. The ultimate overarching goal is to completely eliminate the manual translation layer.
It's about applying Dieter Rams' philosophy at scale.
Yes, removing the non-essential friction so that the product itself can be honest, understandable, and immediately useful.
And if you look at the trajectory of these tools and how rapidly the gap between intent and code is closing, it leaves us with a really profound question to consider.
Lay it on us. What's the final thought?
If AI tools eventually perfect this workflow, if we reach a point where they can seamlessly, flawlessly link a designer's visual intent directly to the underlying back-end architecture without any manual translation step at all, does the traditional binary distinction between a visual designer and a front-end developer simply cease to exist? Will we soon see the rise of a singular role, the product architect who manages the behavioral logic and the aesthetic systems simultaneously? And if so, which half of your current skill set is about to become obsolete?
That is a terrifying and thrilling thought. It forces every professional in this space to look at their daily work and ask, am I adding true structural value, or am I just acting as a human translator? Thank you for joining us on this deep dive into the trillion-dollar blind spot. Until next time, stop arguing over those 8-pixel margins, let the AI write the boilerplate, and start thinking about the architecture.